Our life cycle analysis and redesign is based on a 3-pack of black polyester thread. This type of thread is generally used for connecting pieces of fabric to create clothes or quilts using a sewing machine or hand-stitched using a needle. Polyester thread has several benefits as it is strong and durable in comparison to threads like cotton or rayon and holds dye better than many other textile alternatives.
Dismantling the packaging and the product, we find 8 parts with 4 different materials. The packaging is made up of 2 parts, cardboard and plastic. The cardboard is made from paper containing wood, which is lightweight coated, and the plastic is clear PET. For the product itself, the thread is made up of 3 rolls of 100% polyester yarn that is dyed. This thread is wrapped around 3 tubes made of HDPE to complete the product. The life cycle of the sewing thread begins with the extraction of petroleum, oil, and ethylene, which is a gas, and petroleum must be refined through heating and distillation. Polymer chips are a critical component of the manufacturing process and are produced via polymerization. In the polymerization process, PTA is combined with a chemical called MEG. Both rise to high temperatures. The result of this combination is polyester, which is then cooled and dried, resulting in polymer chips. Polymer chips are melted to make a syrup-like solution. These are introduced into the spinneret, which has tiny holes which regulates the dimension of the yarn. The yarn is then subject to winding and washing where silicone is adhered. Following the application of silicone, then yarn is stretched and slightly twisted and into rubbing, and the rubbing is spun and twisted into single thread. In the process of dyeing, large cones of manufacturing thread are lowered into pressurized vessels, and the dye and other additives are released into the vessels by computer. The dye thread is wound on smaller spool for industrial or home use. The next step is to transport from the factory in China to Semco in Melbourne, who packages it to be subsequently sold throughout Australia. The last 2 steps are the consumer use in sewing machines or manual method, and then to finally end up on the landfill.
In our life cycle analysis, the 3 most intensive sections were the production of components at 72%, processing at 15%, and transport at 10%. Within production, polyester accounts for 95% of the total production section, compared to 3% for the silicone lubricant and 2% for the plastic tube. It is derived from fossil fuels, and the extractive processes involved contribute greatly to the LCA. Toxic substances are also produced if wastewater treatment systems are inadequate, and washed microplastics enter waterways, contributing to plastic pollution. Finally, it is a non-biodegradable material, taking between 20 and 200 years to decompose. The large environmental impact can be reduced through addressing any number of the processes involved in its production, distribution, consumption, and disposal. The life cycle analysis is useful in this sense. It really helps to identify potential points of intervention. As we approached our redesign, we first looked at purported sustainable alternatives to polyester, a natural fibre, corn, and recycled polyester made from plastic bottles. Whilst these are both less dependent on fossil fuels, they ultimately have a large environmental impact, as represented in the table. We reimagined the thread through a localised, community-focused, and systems-based approach. Our investigation led us to believe that this was a more meaningful and sustainable solution. Bella and Carla will now take us through the spin and spool system.
This is our alternative to polyester thread. There were several main aspects we wanted to address in our redesign. We wanted to use natural fibres in order for the thread to be biodegradable. We wanted to reduce transport during production, and we wanted to increase community involvement, as this can lead to greater respect and understanding of a product. Our first hurdle was to find a fibre that we could use that didn't need new infrastructure or many resources. We decided to use pet hair because it is a waste product, it can be spun similar to wool, and it can be dyed as well. This model uses a pet groomer to harvest the fibre, and ideally the groomers would use rainwater for their business. The fibres are then washed, and all the grey water is used on the garden, which is the source of the natural dyes for the next step. We researched what plants were able to be used for dyes, and blueberries, hibiscus flowers, and artichokes were among the potential candidates. Once the fibre is dyed, it is spun into long strands and wound onto spools donated by the community. Incentives are given to those who donate to encourage a steady flow of donations. The threads are then sold by the metre, with any remaining short pieces of thread composted into the dye garden. This closed-loop system allows for the business owner to be in control of the entire process, from production to sale.
So this graphics shows how the spin and spool system works step by step. This has 6 stages, starting with the acquired pet hair, the fibre to be used, followed by the fibre hand washing, natural dyeing, sun-dried, yarn manufacturing, which includes the spinning process, and this ends by taking it to the point of sale. This final illustration shows how the service of the store would work, where the customer can choose the color and the quantity, thus avoiding buying more than the necessary material or packs with colors that are not needed.
In creating our design solution, we looked to the work of Joost Bakker, an artist and advocate for sustainability who has created an intricate zero-waste ecosystem. His project, The Greenhouse, showcases a system which allows for water recycling, homegrown food with zero transport costs, and sustainable building practices. In our spin and spool system, we use a combination of local plants, recycled water, and the surrounding community's pets to create our sustainable alternative. Soft City by David Sim outlines strategies to design for densely populated areas without sacrificing a sense of community. Our design system relies heavily on community involvement, as we need people to use the pet grooming service, donate their used plastic spools, and generally support the thread business. The spin and spool system uses several traditional techniques. Sim references using small-scale production when designing urban environments. Quote, "Rather than looking into complex new technologies to solve the challenges of increasing urbanisation, we can instead look to simple, small-scale, low-tech, low-cost, human-centred, gentle solutions." End quote. So, in order to design for the future, we looked to the past and adapted existing technologies with a focus on sustainability.
To calculate the LCA of our redesign, we added the equipment used within the system. There was a significant difference in the numbers because we drastically reduced the original source materials involved, the transportation costs due to the local scale, and used renewable or human energy sources. Our redesign was guided by Leila Akaraglu's eco-design strategies. The system is efficient through the use of energy sources. Energy is only exerted when necessary, for example through the drop spindles, as opposed to heavy machinery that is expensive to operate and difficult to simply turn on and off as required. The idea of a product-turned-service underpins our design. The thread is produced in-house and the user engages with a spool library, only purchasing as much as required, minimizing waste and allowing the life cycle of the thread to be largely managed from start to finish. This system can be adapted to local contexts to meet the needs of the user in the most relevant way possible. The user is also centered through the promotion of a sense of community and a more personalized approach. This sense of community contributes to the product stewardship present. Reuse of materials and a high return rate to the spool library are incentivized through the offering of discounts following donations of hair or spool. As evidence, social and environmental impact is a central consideration. The employment of systems thinking means that all processes exist to enhance one another and minimize negative impact. Finally, our use of hair, a naturally biodegradable, underutilized, and non-toxic material, drastically reduces the impact of the thread. The same is achieved through utilizing fruits, vegetables, and plants, as well as reusing existing spools for customers. Our redesign is ambitious, because we felt it important to push the boundaries when striving for sustainable alternatives. The realm of sustainable products is littered with marketing ploys, short-term fixes, and solutions that don't go far enough and don't seek to include the community. By creating a dynamic system rather than a static product, we hope to encourage change that goes beyond the material and is inclusive and exciting for all that are involved.